this is a good place where you will see the application of the remainder theorem, like why we need it, okay? So the first part, it's asking find the remainder. So it's just asking for remainder. It's not, it doesn't want to know what the quotient is. When you take this 1000th degree polynomial and divide it by x plus 1. Now here, I am not going to do long division. I'm not going to do synthetic division because it will be like a never-ending process, like a long problem. So because the help of the remainder theorem, I know to find the remainder, what I have to do is, since x plus 1 is what you're dividing it by, I need to find the value of this function, this polynomial, when x is -1. So in other words, I need to take -1 or find what f of -1 is. So take -1 and put everywhere I see x. So minus 13, -1 to the power of 562 plus 15 times -1 plus 26. So from here, I know -1 to the power of 1000 is 1. So 7 minus, this would be 1 to 13. And there's a -15 plus 26. So if I go use the calculator, sitting here for a while, 7 minus 13 minus 15 plus 26, and the answer is 5. So that is what you would get when you, if you do long division or if you do synthetic division, this is what you're going to get. Now, the part B of this question is the factor theorem. What it's saying is, if when you're doing the remainder theorem and if your remainder is 0, then whatever you know, that x equals whatever that number is going to be the factor or the 0 of the polynomial. So the question here is asking, is x minus 1 a factor of, and they have a smaller polynomial. So I'm going to take x equals 1 and plug it in here. So x equals 1 and find the value of x to the power of 567. So let me put 1 to the power of 567 minus 5 times 1 to the power of 400 plus 1 to the power of 9 plus 8. And you know this is 1 minus 5 plus 1 plus 8. So I'm getting 8 plus 1, 9, 9 plus 1, 10, 10 minus 5, the answer is 5. So since I get an answer 5 and not a 0, the answer is no, it's not a factor of that polynomial. If I would have got a 0, the answer would have been yes. Okay, and this is a very good problem to know why always you cannot depend on synthetic division and long division, and you will have to know about this remainder theorem and factor theorem and all those things.